In this course, you will learn all about using HTTP client and the HTTP client factory to integrate with an API. We learned that DTO classes can be shared between client and API by using linked files or a shared assembly approach. But we are mimicking a situation where we don't have control over the API, nor know in what technology it was built. Therefore, we used code generation via NSwag Studio to generate our DTO classes. This requires the API to have an open API description of itself, for example via Swagger. When we use HTTP client, each request travels through a series of HTTP message handlers, and each response travels back through them the other way around. These handlers thus form a pipeline of handlers. Each handler can choose to pass the request through to the next one or cancel it. And that is what is called a delegating handler pipeline. It allows for some pretty cool fine-grained scenarios by creating custom handlers, as we will do later on in this course. Important to know for now is that the default last handler in the pipeline is the sockets HTTP handler, which is responsible for actually sending the request. Speaking of sending requests, it's about time we started doing that. In the next module, we'll dive into tackling CRUD operations. Let's start at the beginning by implementing create, read, update and delete functionality. I'm Kevin and I'll guide you through this module. So in this module we will learn how to integrate with an API. We will cover basic functionality here. We will start with getting a resource, but we will also learn how to create, update and delete a resource. We will soon see that there's multiple ways to do that, from directly manipulating a request and its headers to using shortcuts to do the same. So we will cover different approaches, and from that we will learn what the best practice is. Along the way we will dive into content negotiation. We will learn what it is, why it's important, and how we can work with it. Let's start with getting a resource. In this demo, we will learn how to use HTTP client to get a resource. The first thing we need for that is an HTTP client instance. And we can get that through a factory specifically designed to create and manage instances of it and related classes. If you've worked with older .NET versions, you're probably used to just newing up an HTTP client instance when you need one, but that's not a good idea. I'll get to why that's the case in an upcoming module. For now, just know that the HTTP client factory is the way to get hold of an HTTP client instance. The first thing we want to do is add required services to the IOC container so we can inject such a factory. Let's add the required package via the NuGet dialog. What we are looking for is the Microsoft.extensions.http package. As you can gather from the commonly used types in the description, you can notice that this one has to do with the HTTP client factory. Now let's install. There we go. Let's open the program class. To register the required services, we call into services.addHTTP-client. From this moment on, we can use constructor injection to inject an iHTTP client factory. We want to do that in our CRUD samples class. This will contain all the samples we'll create in this module. So let's open that and let's use a bit of constructor injection to get a hold of that HTTP client factory. Alright, let's add a new method, getResource. HTTP client calls RAsync, so we will have it return a task and mark it with the async modifier. And let's ensure that this method is the method that's called when we run the application. Seeing the CRUD samples class is the one that is registered on the container, and it's the runAsync method that is called on that one. All we need to do for that is ensure that in the runAsync implementation, we call into getResource. As it's an async method, we await that call. And while I'm at it, let's follow a few naming guidelines as well. I believe it's a good practice to postfix methods that are intended to run asynchronously with async. So, instead of naming this method getResource, we name it getResourceAsync. Especially when you're writing libraries or classes that are intended to be used by other people or other classes, writing code like this makes it immediately clear what can potentially go on in the method. Async code in this case. Then let's create an HTTP client instance. For that we call into create client on the HTTP client factory. And let's have a look at that HTTP client instance. There's a set of options we can set here, like the base address, some default headers, the timeout value and so on. These configuration values will be used by the HTTP client instance for all requests. Let's start with the basics and set the base address to the base address of our API. And let's say we wanted to time out after 30 seconds. We're covering additional configuration later on. A small word of caution. HTTP client implements iDisposable, which makes it tempting to write code along the lines of this. Newing up an HTTP client without using the HTTP client factory and surrounding it with a using statement, which ensures that this instance is disposed of once we exit the scope of the using statement. You'll find a lot of code like this in examples online. But this is not a good practice and it should be avoided. We will dive into the reasoning behind this in the module on HTTP client factory later on in this course. But seeing this type of code is so common, I thought it was already important to mention it here. So don't do this. Alright, we've got our HTTP client instance. To get a resource, say our movies, we can now use the getAsync method. This returns a task with an HTTP response message as the type of the resulting object. That matches what we learned in the previous module. There's quite a few overloads for this method. There's one that allows passing through a cancellation token. There's another one that allows passing through something named HTTP completion options, and so on. And a lot of combinations of these. We're covering all these concepts, but for now we're okay with the easiest overload, just passing through the resource URI. What we pass through here, API/movies, is combined with the base address we set on our HTTP client instance. So with this call, we should get a response back and do something with it. So before we continue with the response, we must know whether the request was successful. In other words, whether it returned a level 200 status code, like 200 OK or 201 created. If we get back something along the lines of a 500 internal server error or a 404 not found, we can't just continue. There's a few ways of dealing with this. For now, we'll just call into ensure success status code on the response. This will throw an exception if the response wasn't successful. Alright, let's set a breakpoint at the end of this method, and let's give this a try. Before we do that, we must ensure that we start up both the API and our client, so we choose to start up with multiple startup projects. There we go. And let's build and run this. We hit our breakpoint, so far so good. That means that the call to the API was successful. Yet, if we have a look at the output, we can see that that was indeed the case. We see that a GET request was sent to API/movies, and we also see that we received an HTTP response with status code 200. We can also get that information from the response object in our code. Yet, somehow we cannot seem to get to the actual content. You'd expect to see a list of movies here somehow, right? Well, we need to do a few additional things for that. Let's continue. On the response message, we can find a content property of type HTTP content. But that doesn't directly contain the list of movies as text, as we'd expect from our API. The data we get back from an API can be regular text, but it can also be part of a message that's still being streamed, or a multi-part message. HTTP content is an abstract base class that allows support for all of these. And that also means we must read the data from the HTTP content object. For that, methods exist on that content object, like read as stream async, read as string async, read as byte array async, and so on. In our case, we're going to get back a string, so we can call read as string async. It's an async operation which returns a task, so we need to await it to get the result. And let's store that result in a variable while we're at it. By the way, it's also possible to use .result instead of awaiting this, but that is advised against. .result blocks the current thread, so I would suggest never to do that. You don't want to block a thread. You want the thread to be freed up for additional work if it's no longer needed, and that is why we use async and await instead of .result. Alright, let's set that breakpoint here again, and let's have a look at what this gives. We hit our breakpoint, and if we have a look at the content, we indeed see a bunch of JSON. This is a JSON representation of the movies. So far, so good. We can now use system.text.json, Microsoft's built-in JSON serializer and deserializer, to deserialize this into movie objects. JSON serializer is defined in system.text.json, so let's add a using statement. So we deserialize into a list of movies by calling into deserialize on the JSON serializer, passing through what we want this string to deserialize to, which is an IEnumerable of movie. And that movie class, well, that's coming from the generated DTO models we got from the previous module. So we need to import the movies.client.models namespace for this to resolve. Alright, let's set a breakpoint here again, and let's give this a try. We hit the breakpoint, let's have a look at our movies list. We get back 7 objects. That makes sense, there's 7 movies in our database. But if we have a look at these objects, we see that something weird is going on. All properties have their default values. So what's happening here? Well, the reason for this is that our JSON file is camel-cased and our properties are not. By default, system.text.json will try to exactly match JSON field names to property names, which in our case fails because they're cased differently. But this is easy enough to fix. We pass through a new JSON serializer options object on which we state that we want to use camel casing as property naming policy. Let's give this another try. We hit our breakpoint, let's have a look at the movies list here. And there we go. Our movies are now nicely deserialized into movie objects. But why did we get back JSON? Well, we got that back because it just happens to be the API's default. In other words, the default media type served up by our API is application JSON. But not all APIs default to JSON. In fact, supporting different formats isn't that uncommon. The API we're working with supports both XML and JSON. Let's switch its default for a minute. So I'm going to open the program class at level of the API. Now, this isn't a course on building APIs, but switching the defaults is easy enough. The first formatter in the list of output formatters is the default formatter for output. The first one in the list for input formatters is the default one for input. So with this code, we set both to an XML formatter. Let's run our code again. This time we're crashing on deserialization. And that makes sense. We, the consumers of the API that supports different data formats, just assumed that it would default to JSON. And that's not a good idea. Instead of assuming this, in HTTP it is best practice to explicitly ask for the format we want to work with. Doing so improves the stability and reliability of an application. Let's learn how to do that by looking at HTTP headers.